This question comes from Ethan, who asks, what if all the ice on Earth suddenly became perfectly transparent? My question for Ethan is, transparent like a clean window, or transparent like nature just decided to uninstall the color white? Because at first this sounds harmless, maybe even beautiful. A crystal clear Arctic, glass like glaciers, icebergs that look like floating diamonds, Antarctica suddenly looking less like a frozen continent, and more like the world's largest invisible trap. And for about 5 minutes, people on Instagram would be having the time of their lives. But after that, things would start getting weird, because ice is not just frozen water. Ice is one of Earth's most important climate control systems, and the reason it matters so much is not just that it's cold, it's that it's white. Let's start there. Normal ice, especially snow-covered ice, reflects a huge amount of sunlight back into space. Scientists call this albedo. It's basically Earth's reflectivity score. Bright surfaces like snow and sea ice bounce a lot of solar energy away. Dark surfaces like ocean water and exposed rock absorb much more of it. So right now, when sunlight hits Antarctica, Greenland, Arctic sea ice, mountain glaciers and snow-covered regions, a large fraction of that energy gets reflected away instead of warming the planet. That white surface acts like a shield. Take away that reflectivity, and Earth starts absorbing much more heat. Now here's the key question. If all ice became perfectly transparent, what exactly happens to sunlight? Because transparent does not mean harmless. It just means the light passes through instead of bouncing off. And that changes everything. Instead of sunlight hitting bright white ice and getting reflected back to space, it would now travel into the ice itself. Some of that light would pass through. Some would scatter deeper inside. Some would hit darker ground, ocean water, sediment, or rock underneath. And once that happens, much more of that solar energy gets absorbed, which means the ice stops acting like a mirror and starts acting like a lens, or, in some cases, a greenhouse window. Now, not all transparent materials behave the same way. Real transparent ice would still reflect a little light at the surface, and impurities, bubbles, cracks, and internal structure would matter a lot. But your question says perfectly transparent, which means we are giving nature a physics upgrade it did not ask for. So let's assume the ice becomes optically clear almost instantly. The first thing you would notice is visual. Glaciers would look eerie. Frozen lakes would become terrifying. Every crevasse in Antarctica would go from visible danger to surprise, you're in it now. Ski resorts would become lawsuits with chairlifts. Road ice would become even deadlier than black ice, because now it wouldn't just be hard to see. It would be nearly impossible to detect unless the angle of the light gave it away. A frozen pond that normally looks white and safe would suddenly reveal dark water below. Or worse, it would look like nothing at all. Humans are not built to enjoy walking on invisible surfaces over deep water. But that's just the beginning, because the real problem starts when the sun comes up. Let's say it's summer in the Arctic. Under normal conditions, sea ice reflects a big portion of incoming sunlight. But now the light goes straight through the ice into the darker ocean beneath it. Ocean water is very good at absorbing sunlight, especially compared to bright ice. So instead of bouncing energy back into space, the system now traps more of it. The water below the ice begins warming faster. That warms the underside of the ice, and melting from below becomes much more aggressive. This is important because ice often survives summer not just by staying cold on top, but by avoiding too much warming from beneath. Once the water under it starts heating up faster, the ice gets attacked from both directions. Top down, bottom up. That is bad news for sea ice. Now stretch this effect across the Arctic Ocean. A lot more energy gets absorbed. A lot more ice melts. That exposes more dark ocean. Dark ocean absorbs even more sunlight, which melts more ice. This is called a positive feedback loop, and climate systems are full of them. Once one starts, things can accelerate quickly. In plain English, Earth would begin making its own problem worse. And the Arctic would likely be the first place where we notice that happening at scale. Now let's move to Greenland. Greenland's ice sheet is massive. It stores enough frozen water to raise global sea level by several meters if it melted completely. Under today's conditions, much of that ice stays frozen because it reflects sunlight extremely well. Make it perfectly transparent, and sunlight penetrates far deeper into the ice. Now, this part gets fascinating. In glaciers and ice sheets, light doesn't just vanish. If the ice is clear enough, radiation can penetrate below the surface, and deposit heat internally. That means melting doesn't only happen at the outer layer. In theory, warming can happen within the ice body itself, or at interfaces where the light eventually gets absorbed. Imagine a glacier being warmed not just from above, but from within. That changes the entire melting dynamic. Surface ponds could form more easily, meltwater channels could deepen, internal fractures could expand, and once liquid water starts moving through a glacier, it can lubricate the base, speeding up the glacier's slide toward the ocean. So Greenland would not just melt more, it could flow faster. And when giant ice sheets begin to lose mass faster, sea levels start responding. Not overnight, but not slowly enough to ignore. Now let's visit Antarctica, because Antarctica is where the scale gets ridiculous. Antarctica is cold enough in many places that people tend to think of it as untouchable, but a lot of the ice there, especially around the coasts and on floating ice shelves, is highly sensitive to changes in ocean temperature and surface energy balance. If transparent ice means more solar energy reaches darker rock below, or the ocean beneath floating shelves, or sediment trapped in the ice, then suddenly Antarctica becomes more vulnerable. And the danger is not just melting, it's structural weakening. Ice shelves act like doorstops for glaciers behind them. They slow the flow of inland ice into the sea. If those shelves thin, crack, or collapse faster, the glaciers behind them can speed up dramatically. That is one of the big fears in modern glaciology, even under normal conditions. Under transparent ice conditions, you may be handing the system an extra accelerator. Now, let's pause and talk about snow, because snow might actually be even more important than the ice itself. Fresh snow is one of the most reflective natural surfaces on Earth. That is a huge part of why snowy regions remain cold. Once you remove that bright white reflectivity, land surfaces that usually stay cooler start absorbing more heat. Mountain snowpacks would melt faster. That affects rivers. A lot of the world depends on snow acting as a seasonal reservoir. Water stored in winter, slowly released in spring and summer. If snow becomes transparent and absorbs more energy, that timing gets disrupted. You don't just lose snow, you lose reliable water management. So now we have climate effects, melting effects, sea level effects, water supply effects, and transportation effects. But let's get weirder, because transparent ice would also do strange things to ecosystems. Many animals depend on snowy or icy environments, not just physically, but visually. Polar bears hunt on sea ice. Arctic foxes, hares, and many seasonal species rely on camouflage. If the frozen world becomes glass-like instead of white, those camouflage systems stop working the way evolution designed them to. A white animal on invisible or dark-backed ice suddenly becomes very visible. Predator-prey dynamics start shifting. Species that were adapted for the old visual environment find themselves badly mismatched to the new one, and in the oceans, light penetration through clear ice could alter algae growth beneath the surface. That sounds minor until you remember that algae sit near the bottom of entire marine food webs in polar systems. Change the light. You change the timing and location of primary production. Change that, and you start rearranging who eats whom, and when. Even the biology of the frozen world starts getting rewritten. Now here's another strange possibility. Transparent ice could create optical effects everywhere. Sunlight refracting through glaciers, frozen lakes acting like giant lenses, ice sheets producing dangerous glare, or focusing light unpredictably. Would Antarctica become a giant solar death beam? Probably not in the science fiction sense. The geometry is too messy, the surfaces are not perfectly shaped, and real energy gets scattered and absorbed. But in local cases, clear ice could absolutely channel light in unusual ways and create hot spots, bright flashes, or deeper localized heating. So no, the planet probably doesn't become a Bond villain weapon, but it does become much less stable. Now let's talk timescale. How fast would things go wrong? The visibility hazards would be immediate. The road accidents, hiking accidents, aircraft landing issues, frozen lake disasters, those start almost right away. The melting changes would begin the very first sunny day, but the large-scale climate consequences would unfold over seasons, years, and decades. That's what makes this scenario so dangerous. It doesn't kill you like an asteroid. It rewrites the rules quietly. A little more melting here, a little less reflection there, a slightly warmer ocean, a shorter snow season, a weaker glacier front, a darker Arctic summer, and then, 10 or 20 years later, Humanity is arguing over whether the crisis really started recently, while coastlines are moving, and water systems are failing, and entire ecosystems are trying to keep up with a planet that suddenly absorbs much more sunlight than it used to. And if all of that sounds familiar, it should, because this is actually a more extreme version of something Earth is already dealing with. One of the reasons climate scientists pay so much attention to ice loss is because losing bright reflective ice exposes darker surfaces underneath, which absorb more heat and cause more warming. That process is already real. Your question just takes it to a much stranger extreme. Instead of slowly reducing reflectivity over time, we flip a switch and remove it almost all at once, which means the whole albedo problem gets turned from a warning sign into a global experiment. The kind of experiment no sane civilization would volunteer for. So what would happen if all ice on Earth became perfectly transparent? At first, the world would look amazing. Then it would become dangerous. Then expensive. Then destabilizing. And eventually, if the effect lasted, it would become one of the fastest ways to push Earth's climate system into a much hotter, less predictable state. Because the most powerful thing about ice was never just that it was frozen, it was that it was bright. And if Earth suddenly lost that brightness, it would start keeping far more of the sun than it knows what to do with.